So today I'm going to teach you about organic chemistry. So organic chemistry is basically the study of organic compounds. And organic compounds are compounds that have carbon, hydrogen, oxygen, and sometimes other elements. So all these organic compounds, they can be placed into different homologous series or grouped into different homologous series. So it's like a family. Okay, so each homologous series will have the same functional group, same chemical properties, same general formula, different physical properties, and each member in the series differ by CH2 unit. So it's okay if you didn't understand this at this point, but I will explain to you in detail later. So let's see what are the 4 different homologous series of 4 different families. So we have 4 different families that you need to know are, or homologous series are alkanes, alkenes, alcohol, and carboxylic acid. So these are the 4 different families or homologous series. Okay. So the first thing that I told you was that each member in the homologous series will have same functional group. So for example, alkenes, their functional group is saturated hydrocarbon. Basically, they don't really have functional group, but this is like their identity. This is their property. So they have C single bond C. So they are saturated hydrocarbon. So you will understand why is it called as saturated later. Okay, so hydrocarbon just means that it's a compound that contains only hydrogen and carbon. So it is shown in the name itself. So for alkene, they will have C double bond C. So we call it as unsaturated hydrocarbon. So as long as you have C double bond C, we call it as unsaturated hydrocarbon. Alcohol, they will have OH group or hydroxyl group, and carboxylic acid, they will have carboxyl group or COOH. Okay, so these are the different functional groups that you must remember. So any member of the carboxylic acid will have COOH. So whenever they have COOH, we say that they fall under the same homologous series. Okay, then the next thing that I said was they have same functional group, same general formula. So the general formula of alkene will be CnH2n plus 2. Alkene will be CnH2n. Alcohol will be CnH2n plus 1 OH. Carboxylic acid will be Cn minus 1 H2n minus 1 COOH. So when we do the practice later, you will understand this. Okay, so for now you just need to know this one first. So this is their general formula. So next thing is that, so let's see how does it work. So let's see some examples of the members in the series. Okay, so the first thing that you need to know is at least up to butane you need to know. Okay, so if I have the organic compound have 1 carbon, we will start with the prefix meth. Okay, since it's alkene, we have to end with "-ene", so methane. If we have 2 carbon, we call it ethane. If we have 3 carbon, we call it propane, and 4 butane. So we can fill this into the formula. The general formula was CnH2n plus 2. So what will be the general formula is that, like I told you, they have one carbon. So we just have to put it as CH2 plus 2. So it will become CH4. For ethane, we have two carbons, so we put 2NS2. So 2 times 2, it will become 4, plus 2, it will become 6. This one will be C3H2 times 3 plus 2, 8. Butane will be C4H8 and H10. So they all will have the same general formula. So they fit this formula, and they all have carbon-carbon single bond. Okay. Similarly, for the next one, alkene, you have to start with one carbon. We do not have methane because the functional group of alkene is carbon-carbon double bond. So they cannot form double bond if they have only one carbon. So that's why I left it blank. For ethene, it's 2, so we substitute 2 as the N. So here we have C2H4. For propene, we have C3H6. So just you have to substitute N as 3 here. And butane is C4. 2 times 4, it will become 8. That's it. That's their molecular formula. So similarly, you can do for the rest. For example, methanol, like I told you, have only one carbon. If you start with meth, then we have one carbon, so we can substitute 1 into N. So it will become CH3OH. Ethanol will become 2. So C2, 2 times 2, 4, plus 1, 5. So H5OH. Propanol is 3. So prop is 3. So C3, 2 times 3, 6, plus 1, 7. So H7OH. Butanol is 4. So H, 2 times 4, 8 plus 1, 9. Then OH. That's it. So the way you can remember this is my ear paining badly. So my is for methanol, ear is for 2 carbon ethanol, propanol is paining, and butanol is 4. Okay, so methanoic acid, so you just have to remember we have one carbon, so 1 minus 1, it will become 0. 2 times 1, 2 minus 1 is 1, so it will become HCOOH. Okay, and then ethanoic acid, C2 minus 1, it will become C1. 2 times 2, 4 minus 1, it will become 3, COOH. Propanoic acid, you do 3 minus 1, so it will become 2 here. 2 times 3, 6 minus 1, 5. Then COOH. Butanoic acid, C4 minus 1, so it's C3. 2 times 4, 8 minus 1, 7. COOH. So this is their molecular formula based on their general formula. So every member in the series will fit this formula. Okay, so as you can see that each member in the series, I just added CH2. So from this to this, I added 1C, 2H. From this to this, I added 1C, 2H. So each member in the series differ by CH2. So similarly, I can try it for the other one. So for methanoic acid to ethanoic acid, I just added extra C and H2. So CH2. From this to this, I added 1C and 2H. So I added CH2. So each member in the series differ by CH2 unit. Okay, so that is their molecular formula and naming of the compounds. So how to draw the structural formula I will explain to you in next video. Okay, so last part of this is their reactions. So you need to remember that for alkenes there are 3 reactions. So combustion, cracking, substitution. For alkenes, they undergo combustion and addition reaction. Under addition reaction, you have H2O with H2 and Br2. So the details of this, again, I will have to explain in another video. So alcohol, they only undergo 2 reactions, combustion, oxidation, and in some syllabus they have ester formation. That's when alcohol react with carboxylic acid. So for carboxylic acid, also mainly 2 reactions, combustion and all the acid reactions. So acid reactions are basically acid plus metal, acid plus metal carbonate, and acid plus alkali. So basically that's like the summary of the chapter.